Okay, let's talk about a new vulnerability that has security teams, well, pretty much everywhere, on high alert. It's called React2Shell, and it's a huge deal because it targets one of the most popular web development ecosystems on the entire planet. So we're going to break down exactly what this thing is, how it works, and most importantly, what you need to do about it, like right now.
So the very first thing you need to understand about this vulnerability, which is officially tracked as CVE 2025-55-182, is that score. That's a 10 out of 10. A perfect 10.0. No, that is not an exaggeration. It is literally the maximum possible danger rating a vulnerability can get. You can think of it as the cybersecurity version of a Category 5 hurricane that's about to make a direct hit.
So what does a perfect 10 threat actually get you? In this case, it gets you remote code execution, or RCE. And look, this isn't just about grabbing some data. This is about an attacker from anywhere in the world being able to run any command they want on your server. They can steal everything, install ransomware, use your service to attack other people. It is a complete and total takeover. So here's our game plan for this explainer. First, we're going to dig into what really makes this a perfect 10.0 threat. Then, we'll dissect the attack itself piece by piece. After that, we'll look at how this thing goes from a simple hack to full-on espionage. And then we'll get to the important stuff, your defensive playbook, and how you can hunt for any damage that might have already been done. All right, let's get into the fundamentals. What in the world is CVE 2025-55-182, and why is it causing so much chaos? So, React2Shell is a major flaw in a technology called React Server Components. This is a pretty modern feature used in super popular frameworks like Next.js. The technical reason for the flaw is something called unsafe deserialization of untrusted data. And don't worry, we'll unpack that in a second. But the bottom line is this: it lets a complete stranger on the internet take over your server. No password, no username, no special access needed. So, what does unsafe deserialization actually mean in plain English? Think of it like a mailroom clerk who's supposed to open packages and follow the instructions inside. Well, with this vulnerability, the clerk just blindly trusts every single package that comes in. The attacker sends a package that looks totally normal on the outside, but the instructions inside say, hey, hand over the keys to the entire building. And the server just does it. It's tricked into treating a malicious request like a totally legitimate command.
Now, here's why that score is a 10. It's a perfect storm. An attacker needs 0 credentials. The whole attack can be pulled off with just one carefully made web request. And this is a huge one. It works on default installations. This isn't a case where a developer had to mess something up. And the cherry on top? The exploit code was made public almost immediately, basically giving every bad guy out there a ready-to-use weapon.
So we know what it is and why it's so bad. Now, let's look at how it actually works. We're going to zoom right in on the anatomy of the attack and see how this clever trick is pulled off. The whole thing unfolds in 4 pretty simple steps. First, the attacker sends that malicious web request we talked about with a specially designed chunk of data called a payload. Second, the vulnerable server gets this data and starts to process it, to deserialize it, trusting that everything is on the up and up. Third, and this is where the real trick happens, that payload is built to mess with the application's internal functions. And finally, the server is fooled into running the attacker's hidden code.
This is the core of the deception right here. Normally, a server expects to get a nice, clean, predictable piece of data, like when you fill out a form online. But what the attacker sends is, well, it's a Frankenstein's monster of a data object. It's cleverly designed to point to other parts of itself in a way that tricks the server into exposing its own internal machinery, which the attacker then hijacks to run their own commands.
And hey, this isn't just theory. This right here, this is an actual piece of the malicious payload that researchers at Trendmicro saw being used in the wild. I know it looks like gibberish, but it's basically a command that tells the server's operating system to run a program. In this case, the id command just checks who the attacker is on the system. It's like finding an unlocked door, and from that tiny first step, they can launch a much, much bigger invasion. Getting that initial foothold is really just the beginning. So now, let's zoom back out and look at the real-world impact. How are attackers actually using this vulnerability to go from a simple exploit to full-blown corporate espionage?
The speed here is just staggering. The vulnerability was made public on December 3rd. Just 2 days later, security firms were already seeing it used in real attacks. And by December 6th, just 1 day after that, massive automated malware campaigns were hitting vulnerable servers all over the internet. It was an instant free-for-all.
And once they're in, attackers are opening up a whole bag of tricks. We've seen everything from crypto miners like XMRig, which just steal your server's power to make money for them, all the way to sophisticated backdoors like Hyssonic and Shadowpad, which are often used by state-sponsored spies. They use other tools to download more malware and to hide their traffic. It's a full-spectrum assault.
So, what are they after? Well, it varies. Some attackers are just in it for a quick buck, using your servers to mine cryptocurrency. But many have far more sinister goals. We've seen them immediately try to steal cloud credentials for AWS, Azure, and Google. They're installing backdoors so they can come back later, and they're even running special tools to scan for any other secrets they can find, like API keys or database passwords.
Okay, so that's the threat. It's fast, it's really severe, and it is being used right now. So we've come to the most important question. What can you actually do about it? Let's get into your defensive playbook.
This is, without a doubt, the single most important slide. The only real fix for this vulnerability is to patch your software. Right here are the vulnerable versions of React and the safe, patched versions you need to get to. If you're using a framework like Next.js, you have to upgrade immediately. Go check the official advisories from your vendor to get the exact version numbers. Please, do not wait on this.
Okay, your plan should follow these 4 steps, and this is based on guidance from folks at Microsoft and Google. First, and I really can't say this enough, patch immediately. It is absolutely non-negotiable. Second, prioritize. Start with the servers that are exposed to the internet. Third, while you're patching, get some Web Application Firewall, or WAF, rules in place. These can block the most common attacks and buy you some breathing room. And finally, even after you've patched, you have to assume you might have been hit and actively hunt for signs of a breach.
Now, let's just clear up one major myth that's been going around. A lot of people thought this was just a Next.js problem. That is absolutely not true. While Next.js is a huge target, the fact is that any application using these vulnerable versions of React server components is at risk. It doesn't matter what framework you're using. Understanding that is critical.
And that brings us to our final and maybe most crucial section. So, you've patched your servers. Great. But what about that window of time when you were vulnerable? Let's talk about hunting for the aftermath.
You know, I love this analogy because it really captures the mindset you need right now. Patching is essential, right? It locks the front door so no one new can get in. But threat hunting, that's you sweeping the house to make absolutely sure an intruder isn't already hiding in a closet somewhere. You have to do both.
So what are you looking for? Your security teams need to be hunting for these specific signs. Is your web server suddenly running commands like shell or curl or wget to download stuff from the internet? That's a massive red flag. Look for new hidden folders, new scheduled tasks that an attacker could use to stay on your system, or any network traffic going to weird places it shouldn't be. And if you see tools like Git leaks or Trufflehog running, you know for a fact an attacker is digging for gold inside your network.
And that's really the final thought I want to leave you with. Patching is step 1, and it is the most important step you can take today. But your job is not done until you can answer this one question with 100% confidence. Your servers are patched, but are you absolutely sure nobody got in before you locked the door?